Chapter 7 Review Answer Key / Video Tutorial. So in question 1 it says, what is the simplified form of each expression? So keep in mind for problems like this, we're going to want to get rid of the negative exponent, so that means we're going to put 1 on top and then negative 3 to the second power on the bottom. Well, we can simplify this by taking negative 3 to the second power, which is just 9, so our final answer is 1 over 9. In question 2, we've got 1 over a to the negative 5th. Well, we want to bring this up in order to make the exponent positive, so our answer becomes a to the 5th power. In 3, we've got to move anything with a negative exponent, so the g to the negative 9th has to come up top, so our final answer becomes 5 g to the 9th over h to the 5th. In questions 4 and 5, we're looking to simplify first and then plug in values to evaluate. So in 4, we know we've got to move the x underneath, so our simplified form becomes 9y squared over x to the 3rd. We're going to plug in our values for x and for y. So we've got 9 to the negative 3rd squared over 3 to the 3rd. So negative 3 squared is 9. 9 times 9 is 81. 3 to the 3rd is 27. So we've got 81 over 27. Question 5, very similar. We're going to move the 2 to the negative 2nd up, as well as the x to the negative 3rd. So our simplified form becomes 2 squared x to the 3rd over y to the 5th. We'll plug in what we know. Well, we know x is going to be 2. So 2 squared is 4. So that's 2 times 2 to the 3rd over negative 4 to the 5th power. Well, 2 to the 3rd power is 8. 8 times 4 is 32. And then negative 4 to the 5th power is a negative 1024. So this becomes our answer. Questions 6 and 7, we're looking at writing it with only using the base ones. So that just means we're going to add the exponents. So we have 8, and then 8 plus 4 is 12. So 8 to the 12th power. Here we've got negative 4 and positive 4, and when you add those you get 0. So we get 7.57 to the 0 power. And then question 8 and question 9 are just multiplying exponents with like bases. And so we start these problems off, remember, by multiplying our coefficients. And then we add our exponents. So negative 8, positive 3 gives us negative 5. We don't want negative exponents, so we've got 42 over x to the 5th. We drop the x underneath to make the exponent positive. Here we've got our coefficients of 2 and 5. We add our like-based exponents, so that becomes 13 on the x. Y stays at 10. So our final answer is 10, x to the 13th, y to the 10th. So for 10, we're looking at simplifying the expression. So we can put this in our calculator. We're going to take 4, the exponent button, to the 5/2 power, which in this case is simply going to give us 32. We can do the same thing for 11. We've got 81 to the 1/5 power, which is actually going to be a decimal. It's right around 2.408. All right, in question 12, the first thing we want to do is distribute the negative 9, to just the 2, So we got m to the 7th times m to the negative 18th. Now we're going to add the exponents on the like-based items. So you've got m to the negative 11th. We don't want a negative exponent, so we've got 1 over m to the 11th power. In 13, we want to start by distributing the 3 to the 11 exponent and the 2. So I've got 4j squared k to the 6th times 2 to the 3rd power, j to the 33rd power, k to the 5th. We're going to multiply our coefficients, which is 4 and 8. So that's 32. We add the exponents on our j's. So that'd be j to the 35th. And you add the exponents on your k's. So that's k to the 11th. So our answer is 32, j to the 35th, k to the 11th. In 14, we want to distribute the 5 to the 7 and the 2. So we've got 2 to the 5th, h to the 35th. And then we need to just simplify the 2, so 2 to the 5th power. It's going to be 32, h to the 35th. There's our answer for 14. 15, same idea. We want to distribute what's outside the parentheses first to everything inside for both quantities. So we've got 3 squared, b to the negative 4th, times a to the 6th, b to the 12th. 3 squared is 9. Then we add the exponents on our b's, and so we've got b to the 8th, a to the 6th. Question 16, we're dealing with division. So with the division of coefficients, we just divide, so that's 1/2, and then we subtract our like-based exponents, so -7 minus a -9, which is add the opposite, so it's a +2. So in reality, our answer becomes s squared over 2. For 17, we're just going to multiply our coefficients, so 5 times 3 times 3. Add your like-based exponents. So that's 5 plus 2 for the x, which is 7, and then y to the 6th. So our final answer here would be 45, x to the 7th, y to the 6th. For 18, you're going to subtract the exponents. So that's -7 minus 4, which gives us d to the negative 11th power, which, because we don't want negative exponents, we put 1 over d to the 11th power. (19). Remember, you're going to distribute this to everything inside. So we've got 4 to the 3rd, k to the 12th, over 7 to the 3rd, c to the 9th. Then we just need to evaluate our values, so that's 64, k to the 12th, over 343, c to the 9th. And so that's 19. So now let's look at 20, so I'll erase this. And so for 20, we have a negative exponent, so we need to flip the entire thing first. So that's 4c to the 5th over m to the 3rd. Now this is all to the 4th power. Now we distribute that 4th power to everything inside. So 4 to the 4th, c to the 20th, over m to the 12th. Our last step is to evaluate the 4 to the 4th, so we get 256 c to the 20th over m to the 12th. For question 21, does the table represent linear or exponential function? Well, to determine this, we look at our y values and see how they're changing. Well, each time we're adding 4, the addition of 4 makes this a linear function. If it was multiplying, it'd be exponential, but it's linear since it's adding. In question 22, does this represent a linear or exponential? Well, it's going to represent exponential because we have a variable that is an exponent. 23, suppose an investment of $2,000 doubles in value every decade. Take this function, 2,000 times 2 to the x power, gives the value of an investment after x decades. How much is the investment worth after 6 decades? So this is what we're plugging in for x. So we're going to take f of 6 equals 2,000 times 2 to the 6th power. And in this case, we should get the investment is now worth $128,000 after 6 decades. $128,000. All right, in 24 and 25, we're just going to plug these in our calculators, get our table of values, and then graph. So for 24, I'm going to use x values from -2 to 2. At -2, it's at 0.16. Here it's at 0.8. At 0, it's at 4. At 1, it's at 20. And at 2, it's at 100. And we're just going to plot these. So point right there. Point right there. Point up here. And this is off the graph. So I get the general shape of my graph to look something like this. I'll do the same thing in 25. I'll put it in my calculator and I'll get my x and y values. This time I'm going to use from -2 to 3. So at -2, I'm at 1.25. At -1, I'm at 0.25. 0, I'm at 0.5. 1, I'm at 1. 2, I'm at 2. 3, I'm at 4. So that's the general shape of our graph for 25. All right, let's look at 26. It says, suppose the population of a town is 9,000 and is growing 2% each year. Predict the population after 11 years. Well, the term growing tells us it's exponential growth, so we're going to use this function. All right, and I know that my initial value is 9,000, so A is 9,000. Your rate is 2%, or 0.02, and time is 11. So we just want to plug in what we know. So y equals 9,000 times 1 plus 0.02 to the 11th power. We can plug this into our calculator, and when we do so, we get that the population is right around 11,190 people. All right, so 27 is talking about a compound interest equation. I know that because of the word compounded. Compounded quarterly means 4. They tell us that the initial amount or principal is 700. Their interest rate is 2.25% or 0.0225, and it's after 6 years. So T is 6. So we're going to plug that into our compound interest equation, which we know to be A equals the principal, 1 times rate over N times N to the T power. All right, so we're going to plug this in. So we've got 700 times 1 plus the rate, which is 0.0225, over N, which is 4, to the 4 times 6 power. And so if we plug that in our calculator, remember 4 times 6 is 24, we should get that they've earned $812.90. 28, a population of cheetahs decreases by 12% per year. How many cheetahs will there be in the population after 15 years? Round your answer to the nearest whole number. So we've got our time here at 15. We've got our rate is 12%, which is 0.12 is our rate, and our initial population is 500. So this is exponential decay, so we're going to do y equals the initial rate, 500, times 1 minus the rate, to the 15th power, or times t. So we've got 500 times 1 minus 0.12 to the 15th power. When we plug this into our calculator, we get that our answer is 73.49 cheetahs, which means we want to round it down to 73 cheetahs. 29. A tractor costs $12,250 and depreciates, so that's exponential decay, by 6% per year. How much will the tractor cost after 6 years? So this is T, this is our rate, which is 0.06, and this is our A value. So Y equals the initial amount times 1 minus the rate raised to the T power, in this case time is 6, so raised to the 6th power. And so after those 6 years, this tractor is still worth $8,450.90.